Okay, so with the latest round of distance learning, I challenged you to look at investigation 3.11, and I wanted you to come up with a solution so that when you pushed, or sorry, a solution so that you could have a third menu option with still just having the two switches. Okay, so the reason I kind of challenged it and looked at it is that we want to, if we look at the actual program that they give you for 3.11 and we put it into PICAXE, okay, and we run it. Now, oh, why? What has happened? Oh, right. Okay. So I've already copied it and I've done some formatting to make sure that the formatting is correct for in PICAXE. So in the textbook, you'll see like they'll have begin on the same line as clear F, and that really does not work. The other thing that I've done is I've changed the variable from count to counter, because count is a command. And actually, it looks like I have missed it in a couple of places here. So it will not work if we try to use count as a variable. Okay, and you can tell because it had turned blue. Okay, so that's it everywhere. So if we look at how the program performs, what have I done? Ugh, we need semicolons. Okay, so it's good to see some of these errors popping up if you're just copying stuff from the WJEC textbook. So you need to have semicolons after each one of your labels. There we go. So none of my switches are pressed. It just loops through checking the switches. So if I press switch 0 or switch 1, so it's going to run through task 1, and that's this light is going to be on for 2 seconds. It'll be off, and then it will shut off, and then in 1 more second it will go back to the loop. Okay. Ooh. Oh, sorry, it turns on the second light rather than turning it off. So, all well and good. Now, if I press switch 2, it's going through my second menu option, which is going to have a buzzer on for 1 second and then off for 1 second, and it will loop doing that 4 times. Okay. However, there is a flaw. If I push both switches, it just goes through loop 1. So it just goes through task 1. It never actually checks to see if, both switches are on and do task 2, anything like that. So that is a bit of a limitation of this and OW, because this is still ANDed. Okay, so the 0 flag is still going to be there. So I could, in theory, if I want a third menu option, add a third switch. But hardware is expensive at scale, whereas software is relatively cheap. So if I'm pushing out 1,000,000 units of this wonderful tool, that's 1,000,000 extra switches I have to have and install, and it's 1,000,000 extra points of failure. Whereas, I've got 2 switches. That gives me 3 different on states as well as the off state. So I've got four things with 2 switches. So without having to change anything about my hardware, I can still add a third routine. So I'm going to use some creative use of the 0 flag for this. So remember that the 0 flag is something. It's something that is when your working folder is at 0, or when something flags up the 0 flag, the logic operation was 0. If it's off, then it was not 0. Okay, so I'm going to exploit that using some of the commands. Now remember, only some of the commands will actually trigger the 0 flag. So we go to the list here. These are the commands that are starred that will trigger the 0. So adding, anding, clearing, complementing, incrementing, an inclusive OR. I imagine the exclusive OR does as well. The moving file register, and the subtract function. Now remember, this is subtract the working register from the literal, not subtracting the literal from the working register. And this is the command that I'm going to use to creatively use my zero flag. Now, I'm going to go back to my program. Okay, and I've already got this set up. So let's take a look at what I've done differently. So you can see this is much longer, but I mean, most of it is in my new party time subroutine, which is going to be my third option. Okay, so here I've got it set so that it's going to look at what is the status of port A. It moves it into the working register just like in number 11. I'm then going to subtract the working register from 1. So if my working register is not 1, in other words, if it's anything other than this, it's not going to be 0. So the 0 flag will be clear. So instead of an SS, it's SC. So I won't go to task 1 if it's not this. Okay. Similarly, if I've got this, that's the same as having a value of 2. So if I subtract 2 from it, or if I subtract the working register from 2, I will not have a 0 flag. Right. So if this is set, I will get a 0 flag active. If it's not, I can skip. Okay, now this is the binary equivalent of 3, so if I subtract 3 and it is 0, we're all good. Okay, so now it's going to go to my new subroutine party time. Nothing else has changed. So what I've done for party time is very, very similar to task 2, in that it's going to be a loop, and what it's going to do is it's going to turn on both LEDs and the buzzer for 1 second, turn it off, and it's going to repeat that 255 times because it's a party and we don't want the party to stop. So it's going to run for about 8 minutes because it's got 2 seconds worth of waiting in there. Which, I mean, that's great, except for, well, let's do a run and let's see. Okay, remember, we're running much slower than it actually would. All right, so now we're in this routine. Oh no, I'm stuck in this routine. There's nothing that I can do with my code in order to change this. So, right now, code as is, there's nothing I can do. So I'm going to introduce you to the interrupt service routine. So this is your friend. There are multiple ways to use it. I'm going to use it as a way to break out of this loop and go back to my initial program, the main program. Now, the way that an interrupt service routine works, okay, the way the interrupt service routine works is that when a particular switch goes high, so on our chips, it's default A7. Okay, so it's default this pin right here. When this one goes high, it will stop everything that it's doing, and it will go to the interrupt service routine. When the interrupt service routine is done, it will return to wherever it was that it left. So, I have to go to my interrupt service routine page just so that you can see. So, So the interrupt service routine, there are a bunch of different places that it can take place. We are only going to be concerned with this bit here. So the int con register, we're only concerned about bit 7, bit 4, and bit 1. So bit 1 is the flag. So if the interrupt has been activated, this switches from 0 to 1. If you clear this, it will go back to the main program if you've programmed it correctly. Bit 4 is the actual hardware interrupt. Okay, so this is that A7. If it's detected, this switches to 1. And this is bit 7 is the global interrupt enable. What this does is it enables the interrupt key. By default, it is not active. So by default, this is not active. So we do have to add some code during the initialization in order to turn this on. Okay, so if this is 1, it enables the external interrupt. Okay, so this has to be 1, and this has to be 1 in order for the external interrupt, or the switch interrupt, to work. This has to be 1, and this can be 0 if we want our other interrupts available. Okay, but if this is 0, everything's always going to be 0. It's not going to work. So, for this course, all we really have to worry about is this code here. Okay, so these 2 lines of code will enable the interrupt, and all you have to do is you put them after your initialization. So when you're back on RP0. Okay, register page 0. Okay. You can see here I've also put part of my interrupt thing here. It's just creating something called the working file save. So I've created a variable that will save my working file during the interrupt. Okay, because otherwise I'll lose whatever I was working on. So this is about this. That's this here, protecting your register during the interrupt. So what we want to do is create something, someplace, a box that I can put my working register. Okay. Now, in the template, the interrupt service routine is a bit more sophisticated. It's much more complicated. We're saving the status register as well. If you try to copy this into PICAXE, it doesn't work. And it's fine that it doesn't work because you don't have to worry about it for this course. You're fine with this much more simple interrupt service routine, where we're only worried about saving the register, or the working register. So, here, if we look, I've got everything here, and now I've got my interrupt service routine here. So, this command here will move whatever I'm working on, whatever's in my working folder, it will move to wsave. It's just kind of a default thing. Actually, with my interrupt service routine, because I'm using it as a reset, that's actually not necessary. I don't really care about saving it because I'm actually gonna change the working folder, and I'm gonna move the working folder, or I'm gonna change the counter anyway. So it's not really a big deal. Okay, so here, what this is going to do, this is the test to make sure that it's still got the correct interrupt going. This command here goes back, and it goes back to whatever line it was at before it was interrupted. So if it happened to be here at line 55, interrupt is triggered, it will come back to line 55. Okay. Here, what I've done is I'm going to move the number 254 into the counter. Now, the reason that I've done that is because when I hit 255, okay, that's when my subroutine will go back to begin. Okay, so it'll go back to the top when it's hit 255. Now the reason I did not make the counter 255, well, I meant at 254 instead, is because if I come back here and my counter is set to 255, when I increment it here, it's going to go back to 0 and it's just going to start the whole cycle over again. So making it 254, that means that it will run through this at most one more time, and then it'll be 255 and it'll come back. So it's just a way to make sure that after my interrupt, I go back to my reset. Now I could have my interrupt, do something else. So it's like when I push it, it literally just pauses it. It can loop it for 5 seconds and goes back to where it was. Depending on what your program is and what it does. I just did it in such a way that I'm going to break this loop. Okay, because sometimes that's what you want to do, is break the loop and go back to the start. So you have to end it with a ret FIE. You cannot have a goto in your interrupt. Okay, you'll end up with a stack overflow very quickly if you do that. So gotos, like I can't put goto begin to end my interrupt. It has to be RETFI, okay? Yeah, and here this clears the interrupt flag. So let's look at this and see how this behaves. So, okay, so it's going to cycle through everything just like before. Okay, so I'm going to activate switch 1. Okay, so we can see here that now I'm cycling through here. I'm going to try to hit it when I'm in one of my weights. So I'm in my weight. You can see it automatically went here. If we look at my counter variable is now 254, which is what I wanted it to do. And now if I turn this off, it goes back and it jumped right back in where it was before. Okay, so because this one doesn't loop, it's not really a big deal. Okay, task 2. Once it's done task 1. Okay, again, and if I interrupt, this is actually going to cause some problems if I interrupt in this. Because now my counter, well, it'll just make it run a bit longer. Okay, so this interrupt is not really designed. If I was creating a manual, I wouldn't necessarily say, "Oh, this is good to use during sweat 2." I'd say I would label it in a manual as it's meant to stop task 3. So I'm going to go to task 3. I'm going to speed this up a little bit. Okay, so we can see that it's flashing on and off. So now if I hit my interrupt, sorry, I've messed with the speed of it so you can't really see the thing moving, and I uninterrupt it. Oh, I should probably shut that off. All right, let's restart this just so that we can see. So it did shut it off. We did see that. Why is it not? All right. Simulation we want. Okay, so now we can see it moving. Okay, so we're in the party time. Oh yeah, that's all well and good. But oh god, we need the noise to stop. So I hit my interrupt, I turn off my switches. and I can exit out of my interrupt. It has to go through it one more time, but we're back. And realistically, the odds are, like when you shut it off, it might not even go on one more time. Okay, just because of the way the timings and that work. So, with this, what we've looked at then is some creative uses of the zero flag, as well as the interrupt service routine. Okay, so I think that should be good.